Ladies and gentlemen, programmers, we're going to do part 5 using the while loop. Okay, so in your note, this is a handout. In your handout, brainstorm ways to automatically add 12 keys without having to write 12 lines of code. Write it down on the handout, because the idea is that if you keep having to rewrite lines of code over and over again to add keys, it's kind of a waste of time and it's annoying. So let's try to brainstorm on a faster way to do that. Okay, so concept of loop is a statement in programming language that can execute a section of code multiple times. So the loop is how we're going to get out of writing the same code over and over again. Basically what we're going to do is just take the code we want to do over and over again and put it inside of this loop so it'd go right there. Okay. A local variable is a variable declared inside of a method body. It is used for temporary storage. Okay, write that down. And the idea is int I is a local variable. It's going to only work in this area. Okay. But that int I, okay, so what is the name of the local variable below? Int I. How is it different than an instance variable? Well, int I, as soon as you get to the end of this method, the I disappears. It's wiped out of the RAM. Where on the other hand, an instance variable like key and sound, they belong to the instance of the object or the object, and they last as long as the object does. So they work everywhere. Okay, so key and sound work everywhere. They belong to this guy. They last forever. Int I belongs to the method. It only works here. It disappears very quickly. Okay, so the I belongs to this method, whereas the key and sound belong to the object. Okay, a while loop has the following form. You have your local variable, your I for iteration. So while I is less than 100, so this is going to happen 100 times. And then inside here is where you put your code. And then add this to your handout. A loop has a local variable I that stands for iteration, or the number of times it has gone through the loop. It usually starts at 0 and goes up by 1. So basically, is 0 less than 100? Yes. And then so you're going to do the code here, the statement. And then I equals I plus 1. So now I equals 1. Is 1 less than 100? Yes. Is 2 less than 100? So it's going to go through until I is equal to 100, because 100 is not less than 100, and it's going to kick you out of the loop. So it's going to run this loop over and over again. Okay. Exercise in the key class, write a method definition called play 10 times. It will play the sound 10 times when the correct key is pressed on the keyboard. Okay. So you're going to write a new method called play 10 times. Call on the play 10 times method from your check key press method. So instead of playing, when you press the G key, instead of playing 3i.wave once, it's going to play it 10 times. You will need to use this code to slow it down, greenfoot.delay 5. Otherwise, it's going to go, the act method goes so fast, it's going to go ding, 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 and you're not even going to tell it played 10 times. So use that delay inside there. Modify this form to get it to do what you want. So this is what play 10 times method is going to look like. Int I equals 0, while I is less than, well, that's not going to be 100, but it's going to be, we're going to use this basic form. The statement is going to be play. Greenfoot.delay 5. It's going to slow it down, and then we're going to increment our local variable. Okay, so the idea here is modify this to get it to do what you want it to do. Okay, add the method called play 10 times, so that pressing the key makes the note play 10 times. So here's a good example of what it's going to look like. What will happen if you added 20 times I? See what happens. So the interesting thing is the first iteration through I is 0, so 20 times 0, so it's going to delay 0. And then the next time through I is 1, it's going to delay 20 times 1 is 20. The next time I is 2, 20 times 2 is 40. So it's going to get longer and longer each time. Change the method callback to play instead of 10. Okay, yeah, after you get it to work, change it back to play instead of play 10 times, because it's kind of annoying. Anyway, it was a good exercise. All right, so the next thing I want you to do is turn off make white key. So go into the now we're working in the piano, and you're going to create a new method. So don't delete it. You're just going to just slash it out of the constructor. So don't delete any of your code, right? And if it starts throwing an error, just turn it into a comment. All right, create a new method definition in the piano world named make white keys with loop. Use the loop shown to add the keys to the world programmatically, and call on the method from the world constructor. All right, what do you observe? Okay, so we're gonna make a method in the piano world called make white keys with loop, and you're gonna say int I equals 0, while I is less than 12. So we're gonna add looks like we're going to add 12 keys. Add object, new key, 3a.wave, and I equals I plus 1. Okay. What do you observe? What two strange things happen? Okay, so it's going to do something. It's not going to do exactly what we want. How many times does our loop body execute? What are the values of I during each of the executions? So through the first iteration, what's the value of I? And then the second iteration through, what's the value of I? And then the third and the fourth. Each time we go through, what's the value of I? All right. It looks like only one key was made, but they were on top of each other. How can we change our code so that the keys do not all appear exactly the same place, but instead get placed exactly next to each other? And we have to use the pixels of the key. The key is 63 pixels wide. So this is the symbol for multiplication, by the way, and that's what you're going to have to use that. All right. Next one, what do you need to make sure that the keys are not on top of each other? Change your code so that the keys do not all appear at exactly the same place, but instead get placed exactly next to each other. All right. All right, so using loops. All right, here we have this thing right here, int I equals 0. That's declaring a local variable named I. Here's a hint. There's going to be something in there. Here's the code for make white loops, white keys with loop. What is the value of I the first iteration through? Answer these questions. Okay, so this is pretty close, but obviously you're not going to put question marks there. You're going to have to figure out what goes there. Okay, and then answer that question. All right, here's the quiz for day 5. What does a while loop do? What does the I stand for? What does the I do? How many times will the following loop run? And by the way, notice that it's I equals I plus 2. So you're going to have to kind of go through and check that out. All right, that's it.